Dear students, good afternoon. Today we are going to learn about atomic absorption spectroscopy. After completion of the topic, you will be able to understand the basic principle of atomic absorption spectroscopy. You will know about the different parts of atomic absorption spectrophotometer along with construction and working of each component. You will be also able to acquire the knowledge about different applications of atomic absorption spectroscopy. So the principle involved in atomic absorption spectroscopy, it involves or it uses the absorption of light to measure the concentration of gas phase atoms. Since the samples they are usually liquids or solids, the analyte atoms or ions they must be vaporized in the flame or by using non-flame ionization techniques. So the atoms they will absorb the ultraviolet or visible light and will make the transition to higher electronic energy levels, and we can determine the concentration of analyte from the amount of absorption. This is diagrammatic presentation of atomic absorption spectrophotometer. So here the sample, which is either liquid or solid, it gets vaporized and it undergoes the atomization in the atomic cell. When it undergoes the atomization, it will generate the atom, and this atom it will absorb the wavelength of radiation which is given by the radiation source, which is usually hollow cathode lamp. So the radiation which is absorbed by that atom, it will pass through the monochromator and finally it will be detected by the detector. This is schematic diagram which represents the atomic absorption spectrophotometer, which consists of three basic components. First one is hollow cathode lamp, second is monochromator, and third component is detector. The radiation source which is used in case of atomic absorption spectroscopy is hollow cathode lamp. Hollow cathode lamp, it consists of anode and it consists of hollow cathode which is cup shaped, and it is made up from the element of interest which we are going to analyze. And apart from this, here we are using the inert gas such as neon or argon. So after passing the electric discharge, ionizes the electric discharge, it ionizes the rare gas atoms and which are accelerated into the cathode and sputter the metal atoms into the gas phase. Collision with the gas atoms or electrons, it will excite the metal atoms to higher energy level which decay to lower level by emitting the light. Second component is monochromator. The main purpose of use of monochromator is to isolate the absorption line from background light due to the interference. Third component is detector, where the photomultiplier tube or PMT, it is most commonly used as a detector for atomic absorption spectroscopy. As far as photomultiplier tube construction is considered, it consists of photoemissive cathode and it consists of anode. The inner surface of this photoemissive cathode, it is coated with photosensitive materials such as calcium oxide, potassium oxide or silver oxide. So when the radiation it falls on the surface of photoemissive cathode, the photosensitive material which is present, it will liberate the electron which is called as photoelectron. Now this liberated photoelectron, it comes in contact with the electron active surfaces which are called as dinodes, and when it comes in contact with electron active surfaces, it generates more and more number of electrons which are called as secondary electrons, and these secondary electrons they will get attracted towards the anode which will cause the current to flow. Now finally, the applications of atomic absorption spectroscopy. So the atomic absorption spectroscopy, it finds application in many areas where we can perform the qualitative analysis, we can go for quantitative analysis. Also it is used for simultaneous multi-component analysis. We can perform the determination of different metallic elements which are present in the biological materials, the metallic elements which are present in the food industry, as well as we can also determine the different elements such as calcium, magnesium, sodium and potassium which are present in the blood serum. So this is all about the atomic absorption spectroscopy, its principle, instrumentation and different applications.